Hello, this is part 1 of the short-term scheduling tutorial. Scheduling is actually very crucial for businesses, and it is quite a large and complicated field. Luckily for you, we've only scratched the surface in this course, and we're only going to focus on a couple of basic topics, which are job sequencing on two serial machines using Johnson's rule, and job sequencing on a single machine. Problem 1 in our tutorial is about job sequencing on two machines. This printing company is trying to schedule jobs A through F. We can assume that these jobs are batches of books or something, since this is a printing company. So these batches of books are first going to get printed, then binded. So we're going to be putting these jobs in a queue in front of the printing machine, and then they'll be passed on to the binding machine in that same order. The technique we'll be using is Johnson's rule, and it is quite simple. All we need to do is find the shortest processing time in this whole table. If that processing time is on the first machine, the printed machine, we put that job in the front of the queue. If it is on the second machine, we put it at the end of the queue. Okay, let's look at our example. The shortest processing time here is 3 hours, which is the processing time of job B on the printing machine, or machine 1. So we're going to be putting job B at the very front of the line for the queue. Okay, now we're going to cross it from the list since it's already scheduled. Okay, in the remaining processing times, the minimum is 6, which is job A's processing time on machine 1. So we're gonna put A right behind B in the queue. Okay, next we can see that both jobs C and E have the equal processing times on machine 2. So we can break this tie arbitrarily. We can either put activity C or E at the end of the line and the other one right in front of it. I'm just gonna put them in this order. C at the back of the queue, and then E, and we cross them both from the list. Now we have jobs G and F left, and we can see that F had the shortest processing time on machine 1, so we schedule it right after job A. And of course, D just goes into the remaining empty spot. Okay, now that we have our optimal sequence, we can produce our time phase chart. Basically, we're gonna represent the processing time of each job, and one cell is going to represent 1 hour. Job B takes 3 hours to be processed on the printing machines, so we're represented by 3 cells, and so on. We notice that for the 3 first hours, the binding machine is idle, and at the very end we have a little bit of idle time too. But we can notice that there are no gaps in between jobs, and that's because we used Johnson's rule. The whole point is that this technique eliminates or reduces idle time, and that's it. Thank you for listening.